this was obviously a very controlled environment, so I haven't yet been able to test it in a really loud room, but so far. And this is my cord forming unit. This is the other side. Please excuse the many windows. It felt like a virus pop-up and all that, but I just wanted to show both the code, how it sent the note, and the servos that were on this side out of the camera from my guitar. I just spliced it on to see that it moves when I want it to. And so debugging and designing took a lot of my time. I had wanted to 3D print a chassis to be able to hold the amount of motion that it had, the amount of resistance that each servo would do, because when you play guitar, your fingers are counterbalanced by your thumb as you press on the strings. But I wasn't able to quickly prototype anything quickly because I wasn't able to 3D print. So my dad and I actually have been just working on a wooden chassis, which is still in progress, but yeah, Kaizen. So checklist, strumming module, a mechanical layout, but the chord module was driven through a servo controller, and that was set up through pretty man-made flexible wires that once completed, imagine these strings over here that when they twist, they'll just stick on the strings. Materials and budget, it was a little bit expensive just because of various things that were required, the standards, constraints, and references. And that is my project. Let's open up to Q&A, please.
Thank you so much for sharing your presentation. It's really exciting work.
Thanks.
So please, if you have any questions, send them directly to me, Dr. Junwoo Lee, and then I'll forward those questions to our presenter. The first question is, you mentioned that you use Kaizen techniques for your project. This is something that I see in industry and is continuously used. How do you feel applying these techniques have prepared you to be an engineer?
Most definitely in focusing on simplicity. As engineers, we have a task, and obviously we want to be able to get that done. But there are different routes, and optimization, efficiency, definitely key. We don't want to go too complex, otherwise we lose sight of our vision, we lose sight of our original goal. And so throughout this very wide project, I was able to practice that, a practice of simplicity in figuring out the goal and slight yet steady improvements.
The second question, is this setup intended to work on any guitar?
That was the plan, but then because this is an electromechanical project, I was mostly focusing on the electrical part, because mechanical had so many more in-person testing, can I say? Like on the field, it needs to be hands-on, which I needed a chassis, which due to COVID, I wasn't able to use the school printing, school 3D printer. And so I have actually been playing around with like Play-Doh as models, because it's just malleable and just something I could use. But that was a plan, but as of right now, no, it doesn't.
Yeah, I would love to see the chassis being built because I am interested in playing the guitar in the future. Yeah, I think those are all the questions. So thank you again for sharing your work with us.
All right, thank you so much.
All right, good morning, everybody. So we're going to start right now, 2 minutes before 9:50, and I just want to share the screen with you. All right, so the Quadster. So my name is Sulaiman Abdul Karim, and also I have my teammates.
Hello, my name is Abdullah Al-Kisadi.
And also I have a third teammate as well.
Good morning, guys. My name is Sam Vakili. I'm happy to be here to introduce our Quadster, which is going to be our project. So first, we're going to start on our poster. So the name of our project is Quadster, which is including a drone with 3 different cameras, and each camera has their own function. One of them is just a regular camera. The other one is a night vision, and the last one is going to be VR, which is going to be virtual reality. And also, we're going to put some sensors around our drone, so whenever we drive with it, we can see, sense the obstacles around it. And then I'm going to start with our abstract, which is our drone is a Arduino-based drone. And we're using 2 Arduinos in this project. One of them is our brain, the brain of the drone, and the other one, which is connected to our laptop, which will send the GPS coordination, which was one of the hardest things to do in this project, to make a GPS coordination for our drone. And I'm going to talk about the methodology as well, which one of the most important things that we follow in our project was the safety. We have to measure every piece, every device on this project to make sure that we don't give them too much power or anything might happen to our devices. And we have to make sure each piece is working correctly. And let's see, you can see the pictures, the 2 on top is going to be our schematic, which on the left one is our first Arduino, which is the brain, and the white one is the GPS Arduino. And about the results and the conclusion, I'm going to talk about what experience that we had through this project. It was kind of unique because this project was kind of a bridge from a school to work environment. We have to see deadlines. We have to give our project each step. So it was kind of new, and it was a great experience. We have to work in groups because a lot of times we have to work alone. Well, working in groups was something different. And each failure we had in this project was a motivation to us, because whenever we fix any issues, it gave us more motivation through the project. And as you can see, this is our poster, and this was just a summary about our project, so we can go through our PPT, the presentation. So on the power presentation, I'm going to start again, and the rest is going to be through our teammates. So I'm going to go a little bit in the details. So as I said, our drone is based Arduino, and the most important thing about our project was maintaining the balance and the weight on the drone, because we are putting 3 cameras on it, and we're putting sensors around it. So we have to make sure that the weight balance is perfect. So whenever we're driving the drone in any condition of the weather, we have to make sure that we can drive it perfectly. And I can talk about the coding of the GPS. That was one of the hardest thing. Our three members of us, we were like mostly working on the hardware, and we were kind of all of us having problems with the coding. Like through the search and everything, we started working on the coding ourselves, and at the end of the day, we figured out the codes, and it was like one of the great accomplishments that we ever had, because like most of our work was like on the hardware. Like we took classes through the coding, but we never like focus on the coding. So that was a great accomplishment for us. And as you can see on the abstract, and the objective is one of the interesting things that we figured out. If we built this drone perfectly, we could use this as even delivery purposes, or we could help the in situation like firefighters can use this drone because of the GPU's coordination that it gives to us on the laptop, and the night vision. It will help to detect people, and even if anything will be found, as soon as we get the coordination, we can find a drone. And I think for the rest, I will give it to my teammate, Suleiman.
So we have this the project description right here. So as what Sam said, is the most like challenging thing with our drone is to make a balance in the frame, because we have a lot of weight in it, a lot of functions, multi-functions, not only one functions. So we did put the four motor together, we wire everything, we've set up everything, and now it's the time for a testing to see if it flies or not. And we have the VR connected with the camera set up and everything is ready. Also the GPS, we did have some like difficulties in doing the codes to GPS to read it from the computer and to receive what's going on and like the coordination in the drone while it's flying to receive it. We had a real problem in there, and we fixed it eventually. We did fix it eventually. So we have the work completed. As you can see on the right side, the picture. That's, of course, it's not a new picture. That's an old picture. We're gonna take you in the process step by step to see what we're doing and where we got to. So we had the drone installment and receiver connected. We soldered the Arduino and the GPS shield together for the brain. And also the motor connected, and the ESCs, that's for the motors. It has to have ESC so it can fly, so we can actually, because we're using an Arduino, so we need an ESCs to communicate with four routers. That's an important for the coding, to give it the code to ESC to do the motor, the movements. And we have the GPS code as well. So, in progress, what we're working on in the present right now. I know you guys all thinking like, why is still working on it? But I actually did burn the one of the transistors. So we're waiting for the transistor, which is the transistor is it's the thing that we connect from the remote to receive it on the drone, and I accidentally burned that and start a little fire. It wasn't that big, thank God. But now we're just waiting on it, and we started it working. After that, it burned. So we ordered a new one, and due to COVID-19, it took a while to get here, but hopefully will we get it and everything gonna be ready, because we tested already and it's working. So we are finishing up the camera setup. We do have all the the three cameras, which is the VR, as what Sam said. And also we have a thermal, a night vision / a night vision camera that will help like firefighters to see where's the fire coming from if they have an issue with it, because it's a thermal. It shows the heat, so you can see the heat from the drone while it's flying. And also the third camera is a normal camera. We're gonna have it right there. And so our main goal is to put as much possible in the drone and make it multifunctional, so you only can go to the store and you can find a drone that you can use it in your daily life. in the daytime, at the nighttime, it doesn't matter. If you are a firefighter, if you were a kid who want to play with the drone, there's a VR you can go from there. So we're trying to do that. And at first we were going to use a duct tape to zip it and do everything. That's what we did. And to see if the weight is good and everything. And then we put everything together in the drone, and it's already set up right now. And the most important thing is the balancing, and also the gyro has to be like securely attached to the drone, because the gyro, if any fail happened to the gyro, any troubleshooting, the drone will drops, and it wouldn't working, and it will make damage or probably hurt others while the fly is going on. So we go to the controller right now, and as you can see the picture on the right, that's a transistor that I burned, and Abdullah, my partner, is gonna take it from here from me.
Thank you, sir.
Yeah, no.
Sulaiman. The control in our drone, we are using Radio Link AT10II, and it's come with the receiver and transceiver too, to send the receiver signal through the antenna on the attached to the drone. The range of our drone is 2.5 miles. So we will have a lot of rooms right in it. As Sam mentioned, Sulaiman mentioned, he burned the receiver, and we're just waiting for it we're waiting to receive it, to replace it as soon as possible. As you see in this two picture, there is the destruction board. Is connected to, in the left picture, is connected to the all four motors, and in the right picture, this is the frame of our drone plus the two of Arduino board that we used and the sensor. IEEE standard, we're having actually 8 standard for our project. Go to the other one, Sam. Okay.
Yeah, here we go.
The construct. The first things that we talked about as a group in this project was to make the best product out of the cheapest but good quality part. It is easier to make the project with more expensive part, which some of them have more function on them. We want to make sure the Quadster is capable of working every day. On our goal is to be able to function under the rain, make our drone to function under the rain, snow, and anything like it, and keep the power as like charging as long as we can. Sam,
And we also
yeah.
manufacture the constraints as he talked about it. We want to make it like the battery lasts as long as possible, and the manufacturer with the procedure that we put in the project, it would make it easier, reasonable to reproduce. So, and the safety, that's the most important thing. That's why when I talked about that gyro, that it has to be secured so it doesn't hurt anything. And the feature that we put on the project will help, that, which is the camera, thermal camera. It will help to detect fires, so there's a possibility of any accident, to decrease the possibility of accident, like the little fires that starts that makes a huge fire that nobody knows about after the fact that it got huge, then they know about it. Here's our issues and problems. So our issues was balancing the drones with all equipment. That's really hard part to deal with for the drone. So if you see a drone, it's heavy and it's flying. So I really give a full credit for whoever did it, because now I know how it was going to feel like if you want to try to balance the drone. And the GPS coding, that's pretty cool stuff that you can see the drone where it's going. If you lost it and you can just follow with it on your computer, you can, you know where is it exactly. And connecting the wires together and soldering tightly. Connecting the wires, not a problem. And together, that's easy, but soldering tightly so it doesn't fail while it's flying, that was a hard part as well. And connecting the receiver to the controller, I burned it, obviously. But we're getting a new one, so that will be way better now. Now we know what's gonna burn it, and we're not gonna do it again. So we learn from our mistakes. And that's the GPS code that goes to the computer. And we have another GPS code that goes to the Arduino. And that's our block diagram, how it's gonna work and what's gonna do, where it's gonna go. That's one thing. And that's the drone schematic, as probably Sam talked about it in the poster at the beginning. It was like small, but you can really here see it like in a bigger picture. And do you want to take it from here, Sam?
Yes, so that's our bills on budget. That the total amount would be around 500. It's including every cameras and every controller and everything. And if you go to the next, and that was our timetable, which is it was kind of hard to go through it because of COVID-19. We first had another timetable, then we have to change it through it, but it was a perfect example of if anything happens, you have to adjust to it. So that adjusting helped us through the project, and the project that we got, it was a result of everything that we've been through. So it was a perfect situation. And this is our references. And if Suleiman can click one of them and show them an example, that would be perfect.
Yeah, I'll go ahead right now to share another video just with you, real quick video. As you can see, the firefighter himself, he said it like he will help him to detect the fire. And that's the presentation. Any questions, any concerns, comments? Anytime, we're ready for it. Thank you for listening.
So much for your presentation.
Thank you.
There was a question from audience. What kind of work went into gyroscope controls? I know other drone projects were working on this too.
I'm sorry, can you say it one more time? I didn't get you.
What kind of work went into gyroscope control?
So the gyro, basically, we had to put the gyro in because the gyro is accelerometer, so it controls the drone. So there's a coding for the gyro that we have to put it on the Arduino, and it's gonna communicate with the gyro in a way that's gonna fly, and we can have an easy control from the controller and the code, because the code, it needed to put a gyro in so we can communicate easier and more efficient with the drone using the remote control. It's basically for the coding purposes.
Thank you so much.
Yeah, you're welcome. You're welcome. Thank you for listening.
Thank you for listening. Have a great day.
Good morning, everyone. Welcome to our senior design presentation. We are the wheelchair safety team. I'm here with my colleagues, Chasen Hernandez, Janelle Escobar, Isaiah Dulé, Jen Rosales, and myself, David Gonzalez. We'll start off with our problem definition. Many accidents occur from falling or tipping in a wheelchair, which can result in serious injuries and costly procedures. Often wheelchair users do not have anyone assisting them when accidents like these occur. Design a way to prevent the user from tipping or falling without the need for assistance. Some existing issues. Tips are the most common accident for all age ranges. We chose to focus our design around manual wheelchairs. One study showed that manual wheelchairs tend to fall mainly in the forward and backwards directions. The most common injuries that stem from these accidents are fractures and lacerations, 50% of which affect the head and neck area. These injuries can end up costing the users between $25,000 to $75,000, as well as lead to lengthy recovery times and can damage the users for life. One current solution, anti-tippers, which are on the screen, inhibit motion when turning tight corners and can get caught on uneven surfaces.
For the design, we wanted to reach requirements splitting it into two categories: the critical, which are our needs, and the non-critical, which are our wants. Our mechanism needed to be compact, not adding extra width or length on the wheelchair. Lightweight, cannot add too much weight onto the wheelchair, which can affect the center of gravity. We also needed the device to be automated. Having the device automated ensured that the user can use it without assistance from another person. Non-critically, we wanted our device to be affordable to all users. Lastly, we wanted the device to be able to attach to all wheelchairs. Our device has to meet specifications for wheelchair capacity. American Studies with Disabilities Act, ADA, and National Electrical Manufacturing Association, NEMA standards. Our device needs to support a maximum load of 300 pounds due to the weight capacity of the wheelchair. Also, the device does not exceed a weight limit of 10 pounds. It passes ADA standards of meeting the requirements of going through doorways, minimum of 32 inches, and does not disrupt traveling on ADA standard ramps. Our electrical components are stored into a NEMA standard enclosure, NEMA 4X, to protect against environmental damages.
This is the final design for our prototype. We created a spring-loaded system with pegs that eject straight out and will prevent the wheelchair from tipping backwards. The peg will be locked in a compressed position by spring-loaded pins. The system is automated, so linear actuators push the pins in to release the pegs. These actuators can be seen at the top of each peg housing. Rubber stoppers are attached to the end of the pegs to increase traction and soften the impact. When manufacturing our prototype, we could not find clamps on the market that could attach the pegs to the wheelchair frame, so we decided to machine the clamps from scratch. We also purchased rubber sheets of different thicknesses that we can attach to the clamps to accommodate for different size wheelchair frames. We also designed fixtures that would attach the actuators to the pegs. Because they are a unique shape, we are going to 3D print these fixtures. These are some current issues with our design that we would like to change. When the pegs are in the compressed position, they extend a few inches past the wheels. We want to make sure the design is more compact to improve maneuverability. We would change the position of the bolts so that they are easier to access and install. Also, we want to change the placement of our electrical enclosure so that it does not compromise the folding of the wheelchair. The first image is our prototype in its compressed position. The second image is when the pegs are fully extended and making contact with the ground. To test the strength of the pegs, each team member sat in the wheelchair and leaned back to ensure the system could handle the stress over multiple uses. These are the main steps that summarize the operation of our prototype. When the wheelchair tilts back to a certain angle, the actuators will push the pins in. In the video demonstration, we did this with a screwdriver because we did not have time to manufacture the actuator fixtures due to the current situation with COVID-19. The pegs will be released and locked in an extended position when the pins are caught by slots we machined into the peg housing. Once the pegs are locked in place, the rubber stoppers will make contact with the ground. The pegs will stop the backwards momentum and prevent the wheelchair from tipping.
For the electrical components, these are the parts that we use to operate our prototype. We are using 2 microlinear actuators manufactured by Actuonics. They will be used for each peg individually. These linear actuators provide sufficient force needed to push in the plunger heads. According to McMaster's properties, where we ordered our parts, the plunger head requires 7-pound force to be fully fleshed in, whereas our actuator has a force of 11-pound force, which is enough. We're also using an Arduino Uno to control our system, along with an MPU 6050 gyroscope, which will be measuring our tilt angle. The actuator's extension length will be dependent on the gyroscope's reading of the angle change. So in this demo, you can see that at rest position, which is also a 0 degrees reading from the gyroscope, the actuator is already extended halfway. This allows for a shorter distance needed to extend, thus allowing the plunger head to be pushed in faster. This is programmed to reach the necessary extension required to push in the plunger whenever the angle reaches anything higher than 25 degrees. We also measure for how far the actuator's end should be from the plunger head. With those calculations, we determined that the actuator's extension length from 0 degrees to 25 degrees is the same as the plunger head's length. Therefore, there would be no need to offset their distance from each other.
To better understand our design's behavior, we perform structural analysis on our design using a program called ANSYS. With this program, we are able to analyze the geometry using a finite number of elements to get a more accurate solution than other types of analysis. We analyzed one peg and applied a fixed constraint on the clamps as if they were bolted onto the wheelchair, and also applied a load of 150 pounds, which is the maximum weight each of the pegs would be carrying at full weight capacity. The equivalent von Mises stress solution is shown here. And as you can see, the max stress occurs at the point where the peg housing is welded to the clamp housing. Sorry, the clamp, with a magnitude of 15,655 PSI, resulting in a factor of safety of about 2.55. With that, we know that the structural components of our design are safe for all users as long as the weight applied to the wheelchair does not exceed the capacity of 300 pounds. If the current circumstances allowed, we would plan to make the following improvements on our design, listed in order of priority. First, we plan to add an on-off switch to preserve the battery life of our electrical components and to keep the user safe when the device is not in use. Second, we plan to manufacture a guide slot to prevent the peg from rotating. Third, we would reduce the length of the pegs to make the design more compact. And lastly, we would attach the electrical housing to the wheelchair. Here are the references we used, and we would like to give a special thank you to our professor, Dr. Jinwoo Lee, Dr. Justin Tran for his help with our design analysis, and John Woodland for all his help in the manufacturing process. That concludes our senior design presentation. Thank you. Are there any questions?
Thank you so much for a great presentation. The question from the audience is, did you run any kind of failure analysis?
So we didn't run failure analysis specifically, but I did run static structural analysis. So we're basically just analyzing the structure to make sure it could withhold the maximum weight capacity. And we know that the yield stress of our aluminum 6061 T6 material that we chose was much higher than the maximum stress that would occur at maximum weight capacity.
Thank you so much. Any other questions from the audience? What was the most challenging aspect about your project?
I think, am I unmuted? I think, oh yeah. So I think it kind of we split the work up into kind of sections as we presented them. At least for the manufacturing part of it, there was a steep learning curve with using all of the machines. Previous to this semester, we had never even touched the CNC or been in the machine shop actually. So like for us to actually have been able to had manufactured these pieces right here was a pretty big challenge, at least for our part.
To add to David's point, I think first semester, we had such a broad spectrum of ideas. So really narrowing down those ideas between 5 people was a challenging process, but it was good practice for when we're in industry.
Thank you. Another question from the audience. If the team were to develop a product to commercialize it, Do you think that you'll stick with this design or make modifications?
I think it would have to be pretty modified. We did a bill of materials. It wasn't on here, but it kind of came out a little more pricey than we expected it to. So we'd probably try to at least make it more affordable, so the average consumer could purchase it, especially for wheelchair users as well.
Yeah, adding on to that, because the actuator that we use for this project was manufactured by a like a separate company. We like in the future, if we were to stick to manufacturing this type of project, then we would use our own actuator so that we could preserve like the cost of manufacturing.
Thank you. Another question from the audience. What have you learned from working together as a team?
I think we learned like to appreciate the design process more. Going into this, I don't think we expected it to be this complex, but there really are a lot of steps to design, and it makes you like appreciate every device that's been designed out there and kind of sit back and think like there was a team similar to ours that did work similar to ours, but much more advanced. And like, I can only imagine how complicated much bigger projects can be.
Mm-hmm. And you'll be going out in industry and designing many products in the future. So I'm excited for you. Yes. Another question from the audience. What was the hardest part to manufacture?
I'd say the hardest part to manufacture were those, as David's pointing out in the picture, the back clips. So essentially we had to manufacture our own back clips because we couldn't find ones that were already pre-made to satisfy our needs. And it took us about, I say like 3 to 4 days to manufacture it because we didn't know the process yet, and we had to do tool paths.
Thank you. Knowing what you know now, if you can go back to the beginning of fall, what would you do differently?
I'd say we didn't start to manufacture the items as soon as we can. We kind of waited a little. Took us a couple of weeks to get started on manufacturing. If we started off right off the bat, we wouldn't have been like struggling to. We would realize what we had to do for our iterations to fix them faster.
We definitely would have started earlier. We may have even finished before this whole situation happened. Yeah, would have been more. We probably would have gotten more done.
Thank you so much for answering all those questions.
Yeah, thank you.
Thank you.
Thank you.
Thank you.
Good morning, everybody. My name is John. I'm here with Mana and Nat. Unfortunately, the other two couldn't make it because of work-related issues. So this is the water purification team. So before getting into the whole aspect of our project, here's a little bit of background on what we're trying to focus on. So about 90% of Nigerians lack clean drinking water, and they are also prone to different waterborne diseases. Typically, Nigerian women and children travel a great distance to collect water using buckets and barrels and other related things. And also over 50% of Nigerians live in rural areas that do not have access to electricity. So the objective that us as a group came up with, we want to create a portable filtration or purification system that can and will improve the quality of drinking water, as well as ease the burden caused by the great travel distances to different water sources around rural Nigeria. And then here are the design requirements and specifications that we came up with. First being that we wanted to have a minimum of a 3-gallon container, which is enough for a day supply for a family of 6, which is the average family size in rural Nigeria. Also, we wanted to meet the World Health Organization standards for drinkable water, especially in regards to E. coli, which should be undetectable in a 100 milliliter sample. We want it to be low maintenance and easy to operate. We want it to be portable so that we could help ease the burden of travel since water is usually carried in buckets by women and children. And also we want it to be inexpensive and affordable. So going into more depth into our detailed design, we designed a portable filtering water barrel. It uses two different barrels, a 30-gallon for the outer barrel where the dirty water will be stored, and a 15-gallon for the inner barrel, which is where the clean, drinkable water will be stored. It also includes a handlebar, which allows the barrel to be either pushed or pulled for easier transportation. And the way it works is by collecting water through the 2-inch diameter opening on the top of the barrel. And as the barrel rolls along the ground, the water inside the outer barrel is carried through the filters that is connected onto the 15-gallon inner barrel. So for the outer barrel, we use a U-line 30-gallon drum. It's made of a high-density polyethylene, or also known as HDPE. So the top of the drum has a HDPE removable lid and a galvanized steel lock ring. The lock ring allows the barrel to be transported without the lid popping off. And also the lid includes two screw capped openings, one being a 2-inch diameter and the other being a 3/4 inch diameter. And the barrel is industrial grade and it is dent resistant and durable enough to deal with tough rural conditions. And also, we installed bearings onto the centers of the top and the bottom of the barrel where the handle will be attached through.
So for the filter, we connected the soil water filter to a plastic funnel using self-soothing silicone tape. The funnel allows water to be guided into the filter more easily. 3 of these will be added into the holes created in the inner barrel. The soil squeeze was chosen as it's cheap, requires little maintenance, and filters out E. coli and cholera, in addition to other bacteria and protozoa. In order to attach the filters to the barrel, we used a 3-inch round saw to cut holes into the small barrel, and then used a silicone sealant in order to keep the filters in place and create a water right seal. So for the outer, we used galvanized iron floor flanges as base on both sides of the inner barrel and connected with stainless steel screws to prevent corrosion and all the other stuff. Bolts and sealing washers. The washers prevent leaking from inner barrel to the outer barrel. The nipples can be screwed into the base. After we got the barrels, we created holes on both ends of them to attach the bearings by using a stainless steel bolts. The bearings are for the outside barrel to allow it to rotate easily, while the inner barrel will remain stationary, so we won't need to have any bearings in there. After that, we attach the pipes together by using elbows. The elbows are better for connecting our pipes since it's going to be easy to be changed anytime.
Sorry, I skipped over a slide, but here. So for the inner barrel, we also use a U-line 15-gallon drum, and it is also made of HDPE. But in this case, it is a closed top drum, and it also includes 2 scrap openings on the top of the barrel, one being a 2-inch diameter and the other being a 3-inch diameter. And then we created holes that are placed in a diagonal fashion to increase the area of transmission from the outer barrel onto the inner barrel. And then we decided on this 15-gallon capacity because it gives us about 5 days worth of clean drinking water for the average family in rural Nigeria. And then getting into our demo. So here's a small demo of our prototype before the whole COVID-19. This is the engineering analysis for the outer barrel. So the outer barrel is rolling on the real surface, so it might roll on on rocks or wood or mud. So you can see that the surface of the outer barrel will be changed after a long times of using it. So we made uh, two rubber bikes that will cover the surface of this barrel to avoid damage and it will be easier to move in like wet areas or like any types of that kind. And the material of this barrel is a PE high density, so it doesn't have yield strength in the FEA test, but the data on matweb.com shows that it is 3,000 to 5,500 psi. And then when moving the barrel, the Nigerian people must use at least 500 newtons. And because the maximum weight of the barrel is 15 gallons, it also equals to 550 newtons. And the yield strength of this handle is 2.0310 to the power of 8 psi, which is very high factor of safety when divided by 500 newtons. And then looking more into the bearing housing, the bearing housing is not affected much because it is fixed. So we don't need to have much yield strength, but we worry use it for a long time in rural areas, which is wet and has a lot of mud, so it might like corrode and stuff like that. And then this is the most important part of the project for moving because it needs to have enough strength to handle 500 newtons of pressure and forces, and also for like rural areas, rural weather. So the material of this is chrome stainless steel. So it is good enough for using with water for a long time. And then these are for the bearing screws, which is a material of 1045 steel. And the screws are small, which also have, they have to have a high yield strength of 5.3 times 10 to the 8th power PSI. So the factor of safety is higher than 1 when divided by the yield strength of 500 newtons. And then so for our next steps, we'd like to provide extra protection for the outer barrel surface. And like I said before, we wanted to use bike tires or something similar to that to help prevent too much wear and tear on the outer barrel. And then we'd also like to line the inside of the outer barrel with plastic fins so that it will help carry the water into the funnels of the filters. So that way it could filter out the water and go into the inner barrel. And then finally, we want to connect a 3/4 inch diameter openings of the inner barrel and the outer barrel using a PVC pipe. At least this way, we can connect a removable plastic faucet after removing the cap, allowing easier way for water to be dispensed. And some next steps that we do want to do is that we want to test the water after the purifying process. We weren't able to do this because of the whole COVID-19 thing, so this was prolonged, but we do want to test after the purifying process. And then also we want to test how good the surfaces of the outer and inner barrels, which has the bearings, will be suffered when these barrels are full of water while moving or not, when applying outside, inside, horizontal, and vertical pressures and forces. And then we also want to check and test the bearings area to make sure the longevity of using in rural weather condition. Thank you.
Thank you so much for the presentation. So the first question, the audience said, genius system. Please forgive me if I missed this point, but I must ask, how is it that water is drawn through the filters into the inner barrel?
So there's a funnel that is connected to the filters. And what we wanted to do originally is that we wanted to add fins along the outer barrel so that the water will be carried up onto the top of the inner barrel and into the filter so that it will go through into the inner barrel.
Thank you. If you were to commercialize your device, what changes would be necessary in the future?
We might make it smaller.
Go ahead.
Yeah, we might make it smaller and try to make it cheaper than what it is right now.
Oh, yeah, it wasn't showed on there, but Roughly, we used about maybe like $380 for this project. For what we have so far. That's like not including all the other things like the bag tires and the fins, stuff like that.
What motivated you to pursue this problem? Because this is a really important problem.
I mean, originally we're just like when we were choosing like to be partners in a group, we were just like, okay, we're just gonna join up, and then we're just looking through all the projects, and we're like, oh, this project right here, water purification, that was like a interesting topic that we wanted to like pursue. Like we didn't come up with the water barrel idea until like midway through the first semester, so that was actually one of our other teammates' idea, James. And we're just like, oh, cool. This is a good, interesting idea. A water barrel that uses 2 different barrels to filter out water. But yeah, I mean, originally we came up with different ideas too, but overall we like the water barrel idea.
Thank you. Next question. Why did you choose HDPE material specifically for your design? Any secrets behind it?
I mean, there's no big secret. I mean, it's an affordable material that we could use. Maybe not the cheapest, but it is pretty cheap. And using this type of material, using SolidWorks, we were also able to test for like FEA analysis and stuff like that. So at least that way, it is durable and it is cheap. So we went with that.
Thank you. Next question. Assuming the environment was not so great, such as having bumpy roads, tall climbs, would the user have any struggles? If so, how can you minimize it?
There are some struggles. I mean, we weren't able to attack on this issue because so a struggle that could happen is that like when it is full, it would be filled with water. So at least that way it will be heavy and it's going to be kind of hard to push. So that's like one of the like issues that we were trying to face, but we weren't like fully able to tackle it because of the whole COVID-19 thing. So that's like one of the issues that we're still kind of having a problem with.
Also, we are planning to attach the rubber bike to the barrels, so it's going to prevent the bumpy roads from like hurting the barrel.
In addition to the tires, another question here was, have you considered any possible safety features required based on the terrain?
I don't think we got too far into that, but that is something that we should think about.
Well, thank you so much for the presentation. Those are all the questions from the audience.
All right, thank you.
Thank you, Professor.
The critical requirements of the project primarily come from the client. The client has specifically requested that we use the Nanofin Pro Fogger nozzle, shown to the right. This nozzle is capable of reducing the temperature around a 3 feet area by as much as 30 Fahrenheit and is rated for a pressure range of 20 to 860 psi. The plane cuttings are on the bench, which spans 30 feet by 4 feet, which gives us a required 9 total nozzle according to the manufacturer's specification. Since the missing system will be away from any electrical outlets, the client has required us to install a standalone energy source for all the electrical components, which will be a solar panel in our case. The non-critical requirements come from the client, as well as the idea that has been brought up over the course of the design. The solar panel will require a battery so that the system can operate when the solar panel isn't performing or operating. However, the client will like the option for auxiliary devices to be able to tap into the battery for a short amount of time. The microcontroller that we will be using has the primary function of turning the system on and off based on a timer. Two non-critical design requirements that has been discussed with the client is for the ability to monitor sensor data for the battery charge, water flow rate, and perhaps air temperature for the plants. In addition, the design has been proposed to include 3 different climate zones that allows the user to adjust frequency and duration of the missing nozzles. This is a function that we are focused on, and it allows for optimization of climates for plant cutting based on zone.
Next, we will demonstrate the alpha prototype video, discuss some of our findings, and what we changed in the design to account for these findings.
Very good.
I hope you enjoyed our prototype video. There are two key findings from the prototype that we will improve upon in our design. Firstly, the hanging assemblies leak very slightly due to their punch and insert method of installation. To combat this, we will use a silicone-based water and UV resistant sealant around the insertion points. This has proven very effective at sealing the points of contact from leaking, and the sealant has UV and weather resistance for maximum longevity and durability. Secondly, the water spigot shown in the last half of the video has been a major source of leaking in the system. This is due to being an old part with worn out bearings. The back pressure of the system forces water up and out of the internal bearings. We found that adding a T-joint adapter will give us our own straight pipe to run off of, which removes the possibility of a spigot leaking. Next, we'll be going over the components and the system layout for our misting system. In the next slide, you can see that there is a component list for all of the components for our misting system, as well as a diagram showcasing the full layout. And I'll walk you through that, starting with the upper portion where the line is colored blue. And on the left side, you can see that there's a manual valve that starts the whole system, and it leads to a globe valve, and then onto a filter and a pressure regulator. And from there, it splits into three branches. And these are the three zones that the user can use to have different settings, and each is turned on by a solenoid valve that's controlled by our microcontroller. And so let's move to the electrical portion of our misting system, which is the yellow line. So starting with the bottom right, that is our 50 watt 12 volt solar panel that powers the whole system, and it is connected to our NEMA box, which houses our main electrical components, which is the charge controller, the battery, and the microcontroller.
Okay, so here we have the SolidWorks assembly for our misting system. On the left-hand side, we have the spigot, which is our water source. And from there, we're going to run our pipe up along the steel structure and then back along this horizontal pipe. From a slightly different perspective, we can clearly see the three misting zones, the three branches, and the main line runs along that back pipe there from the spigot before splitting off into those three branches, which each have three misting nozzles. From a third perspective here from the right, I'll point out the three solenoid valves which we operate from the programs of the Arduino, sending an electrical pulse to them to open them and hold them open only for the time that we want them. And then finally we have the solar panel in the northeast side, which has maximum sun exposure while preventing any shadow from being casted on the propagation bench.
For the misting assembly, we start off with the globe valve. It can be turned on and off to prevent backflow. This will be connected to a filter which removes particles that would clog the small misting nozzles. The filter of choice is from the nozzle manufacturer, and it is rated 6 months of usage that can be replaced with ease. The pressure regulator is rated for a maximum of 65 psi. This will prevent any pressure surges from damaging our components. Taking everything we mentioned into consideration, we chose these three products to set up the electrical portion of the system. For the solar panel and battery, we chose the option with minimum energy required that can fit with the system to reduce our budget and maintenance. To avoid electrical hazard, we also need to buy a 4x NEMA enclosure box so we can prevent exposure of the battery to damage or erosion.
We choose PE tubing for our assembly because PE tubing is non-toxic, temperature resistant, and UV resistant. Since our assembly is outdoor and exposed to the sun, UV resistance is required so that the tubing doesn't degrade over time. Temperature resistance is required to prevent water inside the tubing from getting hot and harming the plants.
This is the solar panel kit that we are going to use to power the electrical components. The kit consists of the solar panel, 20-foot MC4 adapter kit cable, 8-foot AWG solar tray cable, 10 ampere charge controller, and finally Z brackets mounts.
We will be using an Arduino Mega microcontroller, which excels at offering support for fundamental measurements such as a digital timer, sensor data processing, and LCD display support. We will use an LCD display for a clear and functional user experience. The user will be able to navigate the program with a series of buttons connected to the board. The microcontroller will operate the main electronic globe valve, the 3 solenoid valves which attach to the 3 different zones, and it will take in data from different sensors that will be displayed to the user. A key function of a particular sensor, the water flow meter, is to recursively determine that water is flowing when it is supposed to. For example, if the solenoid valve is opened, but the sensor does not read any water flow, then the microcontroller will send a flag to the user that perhaps the valve or the sensor is broken. Lastly, we will be talking about our plans for the future. Our budget is $1,000 and our expenses so far sits at $703. We may utilize the remaining budget to add in some of the non-critical design requirements, but we are still discussing with the Arboretum how they would like to proceed. We plan to finalize the Arduino section of our project and then proceed to finish the user manual. However, delays due to COVID has prevented us from accessing crucial components and thus finishing our design. Since the design is to be used by the Arboretum, we have the intention to eventually build the project in the summer, if given the opportunity. Nonetheless, we are committed to providing a functional and effective design to the Arboretum in the near future. This concludes our design. Thank you for watching and have a great day.
Oh, the bottom one, not the top.
All right, well, I hope you enjoyed the presentation. So I will share our presentation slides and we will open up to Q&A.
Thank you so much for a great presentation. Again, if you have any questions, please send them directly to me through Zoom group chat. Here's a question. How did your design change from the beginning to what you have now?
One thing that did change was how we laid out the plumbing. Originally, we were going to have the solenoid valves directly hanging with the hanging or the misting nozzles, and we decided that it was going to be too much weight on that whole assembly, so that we moved them back along that back pipe so that they're more supported and stable. As one change we made.
In addition, another change we made was that we cut down a lot on our budget for cost savings. So, and two of those things in primarily were the solar panel and the battery. We did energy calculations and found that because the system is being periodically used and not continuously used, that the energy draw was extremely low, such that it would almost be worthwhile to not use the battery, but that was more of a preventative measure in case of a power outage or whatever.
Thank you. What were some of the key takeaways, key learning experiences from this project?
So the biggest one that I'm sure all of us will take to heart is that at the very beginning of the fall semester, for about the first 6 weeks, we had a completely different project with much more of a larger scope project. And after the client understood the entire scope that they were asking, they decided to scrap the project. And so we ended up with the misting system that we have now. So working with a real client, I feel that we've all very much understood that in engineering and in design, there's always going to be an obstacle. The design isn't always green lighted. And so you have to recognize that a failed project isn't a failure on your part. Sometimes for economical or I guess reasons like COVID, sometimes projects don't work out.
Thank you for sharing those challenges. Another question from the audience. Do you have an auto shutoff when the Arduino realizes there is a leak or a problem going on?
Yes, so we haven't been able to prototype it, but it is something that we are going to eventually prototype. The main thing would be the recursively checking with the solenoid valves and the water flow sensors. The sensors would talk with the Arduino, and the Arduino would say, okay, is the solenoid valve supposed to be open? Yes. Do I sense water's flowing through this tube? Yes. If so, everything's good. If not, a flag will be sent, and then there are discussions that we would want to potentially auto shut it off with this electric globe valve here in case something was wrong. Like if there is a major leak, we wouldn't want that to just continuously run. So we do have a few things in mind as far as a shut-off, auto shut-off, although the primary function as of now is a manual shut-off for the entire system. So like a hose spigot would be turned off and no water would be able to flow.
Thank you so much. We look forward to seeing your misting system at the Arboretum in the near future.
Thank you so much.
Thank you.
All right, Project Sunflower. We look forward to seeing your presentation. The floor is yours.
All right, so hey, let's start. This is Project Sunflower for the ECS Showcase. I'm Dave. I'll later be joined by Nick and Dusty. So getting right into it. If I can get my computer to respond back to the problem statement. All right, so what we noticed is that in like Puerto Rico during the Hurricane Maria disaster in 2017, that the last remaining community got power restored to them after about 328 days. That's almost a complete year from Vox.com. So we also saw power outage issues in more locally in the Camp Fire of California of 2018. And again, we saw a big problem with Hurricane Maria. So what we wanted to do as a team is we wanted to drill down a way that we could provide a power solution that was eco-friendly for sustainability purposes. Also, one of the things we were concerned about is that if you've lost your power grid, you might also have your access to fuel constrained, restricted, or completely unavailable. And in that situation, you might want to have that fuel that may be scarce available for vehicles that require it. So we wanted to lean towards solar panels. So we do have to be honest, we have to benchmark against generators. That's what we're competing against. So a $1,000 generator that we found on a website will get you about 2.2 kilowatts for 8 hours. A $5.6 thousand unit will get you about 22 kilowatts, and every 4.5 hours, 15 gallons of fuel versus 1 gallon of fuel. So they're very efficient, but you do need fuel. And if that's not available or that's becoming increasingly difficult to obtain, you're out of luck. So with solar panels, stationary unit of 3 panels with 195 watt panels, which is what we utilized, you'd get about 1750 watts per day. With a dual axis solar tracker, you can expect about 45% more efficiency out of it. And this is a 3-hour window on the day. So this is the middle of winter in North America, usable sunlight. So with the dual axis system, we get about 2550, which is enough to power a refrigerator, which is one of our design requirements. Speaking of, we're going to get into design requirements. Take it away, Nick.
Any electrical installation needs to comply with NEC guidelines. That's one of our requirements. We also wanted to power at least a refrigerator or medical device during an outage. Our next requirement is the ability to work anywhere. Some of our desires is to minimize cost, the ease and speed of assembly, and not requiring any specialty parts. We're able to meet our requirements with a NEMA 3R electrical box that's rated for outdoor use. The dual axis system does provide enough power for a small refrigerator, and the solar panel can work anywhere. Dave, back to you.
So one of the main things that we need to do for disaster response is we need the system to be portable. So standard dual axis systems usually are driven while sitting on top of a post. That post is A, hard to dig, and B, stationary. So not very good for disaster response, which is probably why they haven't been thought to be utilized. So what our design did is we decided to build a base box that would act as an anchor. And then that way we could put a actuator to the base box up to the roll cart and drive a horizontal movement. And then we could put an actuator or two on the roll cart to drive the pitch of the solar panels. So this is our finalized design. We went through several iterations. If you guys have, I know you had questions in the last one, we can go over it later. But all of our electrical components are stored in that gray box in the back. That it's a big NEMA box that will hold two 120 amp hour batteries to power the whole system. And this is a single unit. This unit is easy to pack and store and move around. Once your initial assembly of the three major components, the rack, the push cart, and the box are assembled, to put them together and mate them, it's as simple as 1, 2, 3. You have one pivot pin that's from the ground actuator to the roll cart. You have two electrical wires from you have the electrical wires from the solar panels to the battery, and you have 3 pins. You have a pivot pin in the center of the base box, and you have 2 pins horizontal to allow the pitch of the solar panels. So it's easy to put together, it's easy to move. So that's where we're at with that, and now we're going to go into how we drove the system through computer and Arduino. Nick.
The Arduino breaks the UV sensors into 4 pairs: a top pair, a bottom pair, a left pair, and a right pair. It then compares the opposing pairs against each other to see where the light level is greatest and turns to face it, stopping movement when all pairs are receiving equal amounts of light. The circuit diagram shows that we have the actuators controlled by relay boxes because they operate at a higher voltage. Limit switches stop the actuators from over or under extending. Dusty?
With our design requirements, specifications, needs, and desires in mind, there were a few key points of analysis that we've chosen to focus our attention on. Optimization of energy generation or efficiency, automated rotational mechanics and mechanisms, viable modularity and portability for design, tipping resistance due to high winds, as well as durability and reliability. We utilized a variety of corresponding governing equations such as mass, inertia, moment, pressure, and linear and rotational dynamics of linkages to approximate, in theory, the working principles of the design under some prescribed conditions. Additionally, we conducted some finite element analysis on some critical components, running simulations within SOLIDWORKS to acquire von Mises stresses along with deflection to ensure that the assembly doesn't fail under the proposed loading conditions. Finally, Dave helped us fine-tune these numbers by means of functional testing. We begin with assessing the proposed design geometry to ensure that it is safe for use. Since tipping is a hazard of tall and heavy assemblies, especially ones that rotate, we analyzed about how much force or wind it might take to tip the apparatus. Nick constructed a moment diagram and determined that our design would hold up in high winds of about 73 miles per hour, which is within hurricane category 1 conditions. Another concern was how to drive a rotator system. We set up a synthesis of linkages problem using the geometrical constraints and determined an approximate location to mount the actuator while achieving a maximum feasible rocker angle of about 114 degrees, which is about half the yaw required to follow the sun on a summer day for the entire day. Next, since the design remains stable in high winds, we have also analyzed how the dynamic loading of the wind pressure and force would impact the design. We utilized the formula for dynamic pressure and the appropriate constants to accomplish this. Upon obtaining the values for the applied forces on the assembly, we conducted finite element analysis. Using the aforementioned calculated variables for force and applying them dually in worst case scenarios to each of the following critical components in consort with constraining the geometry properly, we arrived at the conclusion that the elements of the assembly will not fail under these same hurricane category 1 conditions, as the von Mises stresses obtained and shown fall under the ultimate tensile and yield strengths. And while the apparatus may experience some deflection, it should not break or fail. Although simply breaking does not imply that it's safe for design or use. That being said, there are some safety concerns and hazards to consider, such as general hazards, tipping, object heft, pinch points, flammability and combustion of materials, and the obvious electrical shock. With these hazards, while these hazards may vary in severity, they are typically the result of common and correctable oversight, things like incorrect assembly or installation, lack of adherence to codes and guidelines, operational interference and disturbances, and misuse. These risks and potential hazards of the user can be mitigated, however, by means of the use of proper signage, complete and thorough instructions for assembly and operational use, compliance with codes and regulations, and we recommend the use of extreme caution and operational recommendation for professional assemblies or installation and inspection. Additionally, emergency shutoffs, service disconnects, contact switches, and proximity or path sensors can be added to the design and installed. Having proven the viability of our design within reason and without further ado, we would like to present to you our working beta prototype.
As can clearly be seen, the upper sensors have balanced, or the upper sensors on either side have balanced the pitch. The sensor suites on the left or right have attempted to balance the horizontal rotation as best it can to track what is literally a race against time for this senior project. Hope you enjoy.
We're available for any questions you may have or want to ask. If not, thank you for your time and your consideration.
Thank you so much for a great presentation. If you have any questions, please send that directly to me through the Zoom group chat. Question from the audience. Impressive. How does it handle rain?
So everything, including if you saw on the video, let's see if I can bring that up real quick. Probably not. Is all enclosed in NEMA boxes or weatherproof boxes. So
UL rated for electrical outdoor use or NEMA rated.
It's a blurry picture, but you can see on the right here in the bottom, those are electrical boxes that are again rated for outdoor use. And all we did is we also used water resistant caulking to completely seal all the electrical components inside. But you can still remove the electrical components if there's damage or you need to do maintenance for any reason because the wiring and the way it's mounted on like computer standoffs, just brass standoffs, so they're non-electrical conductive. And then the rear of the unit is, the prototype is just using electrical boxes, but the full scale would be using a proper NEMA box. We were just trying to keep costs down because the NEMA box is $500 to $700 and it's just unnecessary for a prototype.
The audience said, great, I'd love to buy one. How much does it cost?
Oh man.
So the full scale prototype, with everything, we have to update our budget based on some findings, but we're anticipating about $3,000 for everything. You don't need to pay us a dime. This is going to go, we're going to put this up on Instructables and open source it. We want anyone that has buying agency or purchasing agency, like organizations that respond to disaster relief, governments, to have access to this. We want to make detailed instructions with picture friendly, no written words when available, on how to do it. We also have sourced alternative ways to track the sun besides our Arduino. So that's kind of, because the Arduino is the only really complicated part of this whole assembly. There's a lot of soldering that needs to go into. So if you're not comfortable with that and building out your circuit, there's a all-in-one package that's reasonably priced that is done by a professional solar company that you can buy off Amazon. And everything we bought, you can either go to a local store or you can get off Amazon or you order from 80/20. And we hope to partner with 80/20 and have them basically have a link in a shopping cart that you can just automatically propagate all the pieces you need based on your solar panel selections and sizes. So that's a future goal for that though.
This is a great project. So just to clarify, the $3,000 that you mentioned are the parts that you purchased, which means that if you're the manufacturer of it, the prices might go down significantly.
Yes, if you have access to similar stock as 80/20, or you want to manipulate some of the concepts, or if you're okay just putting things in electrical housing boxes versus a NEMA box, or if you want to run multiple units as a battery bank, you can have all their batteries stored in a centralized NEMA box. These all can reduce costs, but for a single one, the prototype, we were anticipating about $4,000, and we got it down to about $3,000. For our alpha prototype, we spent only about 1,500, but a lot of that was in the battery and the solar panel and the 80/20 stock. You don't have to use 80/20. It just made things simple for side mounting and being able to utilize their channel tracks along up and down the material.
Thank you. You had mentioned that you like to put this up on a website where anyone can purchase the parts and build it themselves, or you even mentioned that you like to partner with 80/20. In order to make it simpler for assembly, what changes would you make so that anyone can put this together?
So when we did the alpha prototype, we decided as a cost saving measure and that we were comfortable enough with putting things together as from previous experience in life, we were going to drill and tap all the holes. But after doing that, I really recommend you spend a little more and have 80/20. They have a boring service and they have an anchor system. Let me show you the anchors. We did all of our SolidWorks utilizing these. If you actually got into my SolidWorks, you see these all over my units, and these just forcibly join the two together. And I cannot imagine it being simpler. On the actual carriage, these 45 degree bars here, they utilize the same technology. So I have them in my prototype, and I was able to experiment with them and really try to break them and play with them, and they don't budge. In fact, my prototype, my upright bar, isn't even mounted to the base. It's just controlled. It's just being held, supported by the trusses. And it won't go anywhere. It's complete. I mean, I've tried to rip on that thing. I've done everything I can. I'm only 220 pounds, so I can only do so much. But yeah, they're pretty solid. So, and plus our stress analysis, I'm confident that these anchors would achieve what we need, and it would be a lot easier to assemble and disassemble. It does cost you about $2 an anchor, and you would have to pay additionally for the bore service. So what we want to do is we want to break it into kind of two packages. One, you're going to do it yourself completely from scratch with you're going to drill and tap yourself, save you some money. Or if you want to make it simpler, you could go with the anchor system. So there you go. I hope that answered your question.
Yeah, thank you so much.
Absolutely.
Those are all the questions we had. Thank you again for your great presentation.
Yeah, absolutely.
Thank you. Thank you.
All right, Retractable Stepping Board team, we look forward to seeing your presentation. The floor is yours.
Okay. Good morning, everyone. My name is Octavio.
My name is Andres.
My name is Troy. My name is Ben.
And we are Team Tabo. We're here to present to you our retractable stepping board. So upon definition, there's approximately 47 million elders in the United States. From those 47 million, around 28 million have a driver license. The current situation that we would like to address is that elderly people often find themselves struggling to get in and out of a chair, especially if they are lifted. So our desired outcome is to develop a way to make it easy for elders to get into any lifted motor vehicles. Due to time constraints, we decided to focus on one specific truck. That is the best-selling truck in California, which is the Ford F-150, according to LA Times. Our goal is to create and manufacture a retractable stepping board for a Ford F-150 truck. Our design requirements / specifications for this project, we decided for a critical, has to be compact so it can fit underneath the body of the truck. It has to be retractable for users to easily use it. It has to be compatible with most 13th generation Ford F-150, as that's the specific model we're trying to go based off on. And it has to be lightweight, at least less than 50 pounds for users to carry and install. For a non-critical design, we came up with, it doesn't have to be aesthetically pleasing, and it doesn't have to be quiet while being used.
For our detailed design, the proposed prototype we are going for is a retractable steps. This product consists of 3 stepping plates, 6 linkage bars, 2 mounting brackets, hardware to hold the design together, and an actuator to push and pull the steps. 3 stepping plates made out of aluminum are connected with linkage bars and rotating pins. The top plate is supported by 2 steel mounting brackets. The mounting brackets are connected to the bottom frame of the truck with bolts and nuts. So on the left side is our SolidWorks model of what our product will look like. And on the right is our actual model, which we were unable to fully assemble. We we had all the components manufactured and bought. We were just needed to assemble it all. So the first component is the plate itself. It is 25.75 inches long, 7 inches wide, 0.5 inches thick, and the material used is aluminum C61T6.
The next pieces are the linkage bars. There are two different sizes. They're both made out of aluminum 6061. The first linkage bar, the smaller one, is 5.5 inches long, 0.75 inches wide, and 1/4 inch thick. And then for the next one, the longer linkage bar, it's 10 1/4 inches long, the width of 0.75 inches, and a thickness of 1/4 inch. The next piece is going to be our mounting brackets. The brackets are made of alloy steel with 2 square pieces welded together. The dimensions for both brackets are they're 0.2 inches thick and then 3 inches by 3 inches length and width. And then lastly are going to be our electrical components that power our system. There's going to be a linear actuator with a 6-inch stroke length, a wireless control system that will control and basically act as our control system for the actuator, and then a 12-volt battery to power it. And then the control system comes with a wireless remote to for the user to use to retract and detract back into the system.
For the engineering analysis, for this prototype model, we use the structural analysis tools that uses finite element analysis to see if our product could withstand a real-world physical behavior of a 200-pound human. The program we used to simulate this are SolidWorks and ANSYS. The first analysis we did was on the 6-inch linkage bar. We ran a static stress simulation to see if our retractable stepping board can withstand a 250-pound human being. This was done by using ANSYS to simulate this behavior. We conducted this on the 6-inch linkage bar, which was supported and which supports and connects the stepping board. For this analysis, we fixed the top hole and applied 150 pounds of force in the Y direction, or in the bottom hole, where we yielded a minimum factor of safety of 8.5. The stress, displacement, and strength and factor of safety can be seen below. Next, we did our engineering analysis on the 10-inch linkage bar, which is located in the middle between the 6-inch linkage bar. The 10-inch linkage bar is responsible for supporting and connecting all 3 stepping plates. For this analysis, we fixed the top hole and applied 150 pounds of force in the middle hole, where we yielded a factor safety of 12.6. As a result, we were able to conclude that the 10-inch bar was able to withstand the distributed force of 250 pounds. Next, we did our analysis on the stepping board, where we conducted analysis on the board located in the middle. The board is responsible for supporting the weight of the user during usage. For this analysis, we fixed each hole on each of the end of the board and applied 250 pounds of force in the middle of the board, where we yielded a factor of safety of 2.7. As a result, we were able to also conclude that the stepping board can withstand the force of a human being weighing 250 pounds. Lastly, for the simulation, we tested a worst case scenario where if a human was to stand on it right in the middle of the plate, where we yielded a factor of safety of 200 or 2.5. 2.5, yeah.
Next is going to be our manufacturing process. Top to bottom, left to right. First picture is going to be the bracket that's bolted onto the plate. Next is going to be the plates that were water jetted out. And then next we're going to be the water jet used at the Cal State Fullerton's machine shop, where we cut the material. The linkages are going to be all the way to the right. They were cut out using REM material, 1/4 inch thick aluminum 6061. On the bottom is going to be some basic tools that we use as a tap guide, tap handle, and tap to tap the holes to mount the bracket. Then you can see the team working together. We created a wooden fixture to hold the stepping boards together. And then lastly, you're going to see a weld station where we welded the steel plates together to form the bracket.
And lastly, we had some, like how we stated earlier, that it wasn't complete all the way due to certain circumstances. Things we just need to finish up is just install the grid tape on the stepping board itself to apply to withstand within codes. We have to paint the assembly. It's for painting assembly is basically just worrying about corrosion occurring during outside weather temperature. And a safety cover guard as well is to withstand any like pinching issues if the user were to put his hand towards the linkage boards. And finally, will be some actual modifications to extend the stroke length, as we still haven't we weren't able to fully assemble the whole prototype. Thank you for your time. If you have any questions, please, or feedback, please let us know.
Thank you for a great presentation. Again, if you have any questions, please send them through the Zoom group chat directly to me. So, question from the audience. For future, are you looking into other trucks in addition to F-150, like Toyota Tacoma?
Yes, we are. As long as we just need to change the mounting brackets. So we will provide various types of mounting brackets that will stand on different models of the trucks. So we, if everything goes good, then yeah, we will apply it to other specific vehicles.
Thank you. Another question from the audience. What's the expected lifetime of the apparatus?
That's a good question. That wasn't something that we really looked into too much as for life cycle or lifetime of the system. That would have been a good analysis to run and see how long it would last. But I think as of right now, we don't have an answer for the lifetime for the system.
Thank you. Is fatigue an issue for your device?
No, I wouldn't think fatigue would be an issue. I mean, we ran tests at pretty much the worst case scenario, and the system held up. Unfortunately, we weren't able to assemble it fully, but we did do a test where I stood on the plate itself and it held up. But since we didn't, since we were unable to fully assemble it and mount it to the wooden fixture to test it, we didn't go past our 250-pound limit. But as for fatigue, there weren't any issues with what our goal was.
Another comment is, I really see this going big. Keep up the good work.
Thank you.
Any other comments or questions for the team? If you were to scale this, so you're supplying this for multiple trucks, what changes would you make?
I think the main changes we would do is probably the mounting brackets. Since every truck or car has its own specific bracket, that would be the changes we would make.
Yeah, I think that, or even the length of the stepping board itself, or even make sure that there's enough clearance from the ground to the bottom of the plate. I know there's a lot of regulations with height, and from step to step, there has to be a minimum height requirement. So I think that there would be three main variables that would change depending on the type of car.
Thank you so much for answering those questions.
No problem.
All right, thank you.
Thank you.
Please welcome the future pioneers. We look forward to seeing your presentation, and the floor is yours.
Okay, well, hello everyone. We're the Future Pioneers, and we made a beach machine cleaner for our senior design project. My name is Jorge Duran.
My name is Rashid Aloteba.
Mahmoud Al-Mutari.
And there's one more, Majid. I think he's having technical issues. So starting with our project, I'm just going to bring you guys up to speed a little bit of what we've been dealing with and some terminology. So we are dealing with debris. You know, what is debris? Well, it's a material that's been manufactured or processed that's been disposed of, like either into the streets or to the ocean. You know, like styrofoam cups, plastic bags, anything really that could be manufactured. And with all this debris going on, mankind started making what's known as the Great Pacific Patch. For those of you who don't know what the Great Pacific Patch is, it's a collection of marine debris floating around the Pacific Ocean. And there's a lot of patches, one of them being on the eastern hemisphere where we're located at, and another one in western where Japan is at. And the Earth has these natural gyres happening that are moving the marine debris around into one convergence zone where all the trash is collecting together. Now, as all trash starts flowing around, most of it ends up in our beaches, and that's why we decided to create a beach clean machine to clean up our sand. One of our design requirements was that we really wanted to design this for easy transport, so we wanted to make it compact to be able to fit any short bed pickup trucks, you know, like a Ford F-150, a Toyota Tacoma, you know, anything short bed is that people are comfortably driving. Another critical thing was that we want to make sure that this machine is an easy operate use for any operator, and obviously that it's efficient in cleaning. So we put like a 50-gallon bin in the back, so that way the operator doesn't have to make trips back and forth.
And yeah, for the engineering standard, guys, we looked into it to take under consideration the safety and the efficiency of our machine. First, we looked into a standard code ISO 1420. This will be covering the moving parts to ensure the efficiency and the safety of others. The other one is the IEEE 1986. And since we are working with water environment and we have an electric components, that will be ensuring the efficiency of the electric components. And of course, we have considered the shut-off emergency switch by looking into the standard ISO 13850. And the other code we chose is the G2060. It's for the engine, specifically for the light utility. And the last one, as you could see, the ANSI 2070, that's for the non-pneumatic tires for photolysis purposes. Next slide, please. And yeah, this is our machine that will pick up the trash, as you can guys see it. We first started by making the chassis. We chose 10 feet pipes, and we had to learn how to weld. And we made the chassis according to the previous, according to the drawings of the dimensions we had. We will be using two engines. One engine will be responsible for the ATV wheels, which is 4 wheels, and the other engine will be working with the raking mechanism. And you could see, guys, the raking mechanism, which have like a scooping sticking out of it. It will transfer the waste in a clockwise to throw it into the storage unit. And Majid will continue now talking about his part.
For the first engine, it will be the mobility engine. It's gonna be a Lifan engine. It's this engine have a 3 horsepower engine with 79 cc. It's a 4-stroke OHV industrial grade gas engine with a recoil start. It has also 5/8 keyway shaft with 0.37 gallon fuel tank with the automotive grade rods, piston rings, and crankshaft. Also, for this engine will have the ability to drive our device smoothly, because on the first semester we have decided to get a smaller engine, but we have changed it in this semester. For the second, and this engine will be connected to the axle under the chassis. It will be connected with the chains and sprockets. For the second engine, it will be Honda GX25 engine. It has a 1.1 horsepower at 7,000 RPM with maximum torque of 1.25 Newton meter at 5,000 RPM. And this engine will be only for the raking mechanism because we need a light engine. This engine weighs only 6.8 pounds, so it's almost the world's lightest OHC engine. Also, it has a fuel efficient with a high output operation, and also it's easy to drain and refill oil, easy to maintain and use. Also, we have considered while doing the powertrain calculation, the mass of the body, acceleration due to gravity, inclination angle of the gradient, normal reaction of the body to the surface, and frictional force. And also we have also this will be the minimum power required to provide the mobility to the whole machine. We will, however, multiply this power with a factor of safety of 6. This is to cater for cases where our scooping mechanism may get stuck in the beach sand. And also for our designing purposes, we have assumed our machine to operate on a maximum gradient of 15%. And also for the Honda GX engine, in order to calculate the maximum torque required for the sprocket, we need to consider all the forces acting on one of the sprockets. We had 4 forces to consider: the weight of the blades, the sand and the waste, the weight of the sprocket shaft, and the chains. To get the total weight of the sand being lifted, we had to determine the volume of the blade and multiply it by the number of the blades. Then multiply it by the density of the dry sand. So also we have got the Honda transmission because the engine have a very high RPM. So we want to reduce the RPM to as much as possible. So with the engine with the transmission will have 250 RPM maximum. So that's gonna be the racking mechanism engine. And for the wheels, we are going to use ATV wheels. These tires were designed to be lightweight and offer great flotation for maximum performance on the sand, provide more traction on unpaved surfaces, such as loose dirt, mud, sand, or gravel.
So for the engineering analysis, we have done an FEA analysis on SolidWorks on all the components of our device. And we made sure all of the components can withstand the forces and loads that will be applied on it. The most challenging part in the engineering analysis was figuring out the speed we want our racking mechanism to operate at, and figuring out the most suitable sprocket chain combination that will ensure longevity and easy maintenance. So for 30-inch center-to-center distance between our axles of the racking mechanism, we have 2 big 14-inch, 14-inch diameter 30 teeth on the upper axle, and on the bottom axle we have 2 5-inch diameter 11 teeth sprocket. So connecting these sprockets, we used a Tsubaki double pitch attachment chain, which was shown in the model sub-assembly. It has a pitch of 1.5 inches. We plugged all these numbers in the equations to find out the number of links we need. It turned out that we need 61 links, which correspond to 95-inch of chain length. And also, this will allow us to use a number of 15 blades, maximum number of 15 blades. This allows us to be efficient, very efficient in cleaning. And the second part is determining the maximum speed of the racking mechanism. So we took under consideration how far the debris, we want our debris to travel from the top part of the racking mechanism to the garbage unit. And we found that the speed, the perfect speed for the racking mechanism would be 167 RPM. Thank you guys for listening. And if you have any questions.
Thank you so much for a great presentation. If you have any questions, please send them directly to me through the Zoom group chat. The question from the audience: how does the driving mechanism attach to the bucket and the chain system?
So originally we were going to connect the chain from the motor up top, but dealing with chains and the mates is really difficult. So I know how hard it is to see with the design. But we have sprockets attached to the motor and the shaft of the braking mechanism, and we'd be able to connect the chain that way. So what you see here, and in terms of the trash going into the bin, the little fins that you see it riding all the way to the top on the incline. As soon as it gets over here, this bin is collecting all the trash that'll fall in. Hope that answered your question.
How much trash are you hoping to remove with your device?
Well, this bin was designed to have a max capacity of 50 gallons. So a regular household trash bin is around a 13-gallon bag. So figure around 3 household bags in one travel. So we're hoping to at least try to be able to clean one beach. In terms of like the exact number, it's a little hard to say.
What are some other design changes that you hope to implement if you want to commercialize your product?
We would definitely cover every sprocket chain connections to make sure operator is safe from getting in contact with the chain.
Majid also had some interesting different design changes. You want to tell them about it, Majid?
Yeah. Also, we want to attach the first engine, the Honda GX engine that will be responsible for the racking mechanism. We want to attach it under the trash bin. So we will have the ability to even remove the engine for maintenance, and also we will be able to cover the chains throughout the device.
So to sum it up, like we have to plug all the standards that I already explained to ensure the efficiency if we want to commercialize this, and to make sure it's work and ready to sell.
And also it will include a kill switch for the engines.
Also, one of the changes we made is we added the front cover, as you can see on the lower right picture. This front cover will ensure that the debris are not flying away from our device. Instead, we ensure that the blades can scoop up the debris and take it all the way up to the trash unit.
Again, thank you so much for the presentation. Those are all the questions from the audience.
Thank you.
Thank you for listening.
Thank you.
All right, I'd like to welcome our next team, Solar Decathlon.
Well, thank you for having us.
The floor is yours. We look forward to your presentation.
All right,
Yes,
well, first I want to thank everyone for sticking around. My name is Scott Daniel.
I'm Andrew.
I'm Con.
And unfortunately, Nick was not able to join us, but he's definitely here with us in spirit. And once again, we are the Solar Decathlon here at Cal State Fullerton. So, as kind of an introduction, I'm sure you're wondering what exactly the Solar Decathlon is. And to be specific about it, it's put on by the Department of Energy and specifically their National Renewable Energy Laboratory over in Golden, Colorado. It's an annual competition for the design, which is basically just a theoretical thing. And they do a biannual build competition, which we might have liked to do, but you actually have to build something that's quite expensive, and we're just still trying to get the project off the ground. As such, because it's a theoretical thing and we have to build something for senior design, we decided to take an aspect of the building and put it and be able to build it and put it back into the project itself. And to do that, we decided to choose the AC unit from the building in order to kind of get a renewable energy thing, try to build something that was a little bit lower cost than what you would normally expect for an AC unit. And like I said, put it right back into the building. A little bit of the way we went about trying to do this, some of the programs we use SolidWorks because all of us are pretty much familiar with that. SketchUp 3D, which some of you may not be familiar with, which is primarily an architectural tool. For analysis on the building, we did that through ANSYS, as well as using NREL's own software called PAT, which is specifically for buildings. For more schematic things, we did AutoCAD just because it's very good at 2D, and trying to do that stuff in SolidWorks or one of the other programs is a little bit weird and can be a little bit hard.
For the project goals and objectives, we wanted to make this, important. So we decided to use our design to address a societal crisis. And what we decided to address was affordable housing and the job market. So our design was a mixed-use multifamily, so basically an apartment complex with an additional commercial use at the very bottom. It was to be renewable energy and supposed to be net positive, which means it creates more energy than it consumes. And it had to be high performance, so the energy use intensity had to be under a specified amount for our division. And like Scott said, for the build portion, we decided to make a liquid desiccant AC unit. So design specifications in specific, for each of the dwellings, there was a square footage that were required. And we had a limitation for our stories, so it couldn't be too tall, although we didn't have a limit to go underground. And the Department of Energy had standards for us for the the Energy Ready National Home National Program, by which it had to be livable. It had to be mostly residential, and it had specific lighting allowances in order to keep to a specified energy usage. Despite design specs for our AC unit are, as you can read there, it had to fit through a doorway and be able to characterize its performance through LCD screens, and preferably be under $1,000 for the final build. And the project results were that we were able to submit the introduction. We found out that homelessness itself, because that was our initial crisis that we wanted to address, is not really viable for profit. We did partner with the business team, so they helped us decide that it's not really profitable to help the homelessness. So it would be more of a charitable cause. And so we decided to address affordable housing instead. Andrew modeled out 3 apartment sizes. We finished a really simple analysis model on the building and the AC system. And the business analysis was completed with the results that I just mentioned. So continuing on the project results, we have the schematics for the units complete. We didn't make it to the competition, and we didn't finish a lot of things. We did finish the wall though, even though it's not on this presentation. I paid for the wall.
All right, so the majority of my work was designing the whole building in SketchUp 3D. So these are some of the pictures of the final building. It's all the shipping containers grouped together, 5 stories high. And so the studio, we had a studio, a 1-bedroom and a 2-bedroom. And these are the layouts of studio, the 1-bedroom, and the 2-bedroom.
And then for the actual AC unit, this is a model we did in SolidWorks. It was one of the more preliminary models, but it was kind of what we were looking for in the end anyways. This, as soon as it moves, is a little bit more of a detailed of one of the cooling portions of it. It's basically to help regenerate the desiccant, because the desiccants do have a certain capacity and you have to regenerate, otherwise you just have to refill it, which usually isn't the best.
So this was a schematic for the planning of the thermodynamic cycle and the functioning of our AC unit. As you can see by the green cycle, that's the cycle of the desiccant. The purples are air, red arrows indicate heat, and blue lines and arrows indicate water.
I threw together a wiring diagram for the solar panel that's connected to the AC unit. And we have a couple fans, a pump, and then the convective heat source with the battery. Oh, sorry.
Okay,
the, connected to the wall, and then an AC voltage source with a converter in there as well.
So I ran the sample cavity analysis in ANSYS. So we found out that in ANSYS, whatever figure that you put in there, it will assume that it's a cavity and run the fluid through it. So we had to create a separate model completely from the original HVAC that simulated what the spaces that the airflow looks like is. As you can see, there's a sprayer, and here is the kinetic and energy momentum graphs over time. So there's an initial push, and then it settles out steady state to be a little bit, sorry. Yeah, to be consistent. So the flow inward came from the bottom at the curved pipe, and there's also an input at the top for the desiccant sprayer. Here's the Arduino that we referenced in order to control for the thermostat and the readings.
And this is the build that's currently going on. Unfortunately, Nick is the one who's primarily doing this, and he's not with us, so he'd be able to explain a little bit more exactly what he's done. But it's coming along quite nicely. There's a little bit more to go, but the initial stacks and kind of the, I mean, it's coming together, which is really nice. So another glamour shot of it. So the other thing is kind of how did we get the word out? And one of the things is we did participate in the Decathlon. We did it this year. We also did it last year, which we were a little bit more successful. There was obviously the showcase that's going on right now. I'm actually in the management class, and as part of it, we had to go to a group of investors and actually do a video presentation for them. There's a Tau Beta Pi picnic, which we'll be talking about tomorrow with our little group. There was SCUR last semester, there was the Discoverfest last semester, and then we also did a little thing this semester at the Welcome Fair. So thank you everyone for listening. I hope it was informational and fun, and we try to keep it a little bit lighter because I know a lot of these can start to drag on after a little while, but I hope you guys enjoyed it. So, and questions? Questions.
Thank you so much for sharing your work with us.
All right,
And
thank
if
you.
you have any questions, please send them directly to me through the Zoom chat. So a question from the audience. Are there plans for integrating the entire system and the apartment complex?
You want me to answer that?
Yeah, go ahead.
Are you talking about the HVAC system into the complex? Then the answer would be yes. It's not going to be a central system. We found that it'd be more efficient to have a single unit for each individual apartment unit.
What were some challenges that you faced during this project?
That's one of those ones where every step of the way there's a challenge. I mean, just learning about how to get everything done was a huge challenge we had to overcome. Thankfully, Khan managed to actually get some employment at one of the places through the Decathlon. And we went there once. We had contacted him a number of times. It's just information. I know it's not really specific, but there's just so many things. If Connor or Andrew have more specifics, I'll let them chime in.
I had a lot of learning curves with SketchUp, the architectural program, the software program. That was really, there's a big learning curve with that, trying to design the whole building using that software.
Yeah, and I personally had never touched an Arduino or a breadboard or any of those things before. So this month was the very first time I touched those things. So I learned a lot of new things as well.
It's great to hear that you learned so much from this experience. Another question from the audience. Do you think your design is worth implementing in some of the Middle Eastern countries where the temperature could reach up to 130 degrees Fahrenheit and households spend a lot of money for cooling? Will it make it cheaper for them?
Our design, I think we made it specific to California, which is what the liquid desiccant part for it would be. I know that some places in the Middle East are humid, but some places are not. In the cases that it's not humid, like we could take out the liquid desiccant portion of it, so it would essentially become a swamp cooler.
Thank you for that answer. Another question from the audience. What considerations were made for sunlight entering the apartments?
I made sure that on both sides, so natural airflow and natural sunlight into the apartment buildings. And also for the bathrooms, I thought about like ventilation, because for code you have to have ventilation for the condensation after taking a shower. So I made sure that there was a window in every bathroom.
Another question from the audience. Are you all mechanical engineers working on this project? Because
Yes.
it seems,
Yep.
I will say we did have some what we call the auxiliary members. So like some of the like Baja and Rover and ones, they actually go a multidisciplinary thing. So you have tried to pull in other disciplines because as mechanical working on buildings and such, it's not the greatest because we don't really have that specific knowledge, but we struggled through. I think we did a good job at it.
We did have some auxiliary members that weren't mechanicals. SB was electrical, and we did have some help from some civils that were on the project last time, but we're not on this team.
great job. It's hard to work on interdisciplinary projects, and you just continue to learn how to learn.
Exactly.
Yep.
Yeah.
Well, those are all the questions from the audience. Thank you again for a great presentation.
All right.
Thank you,
guys
Dr.
so
Lee.
much.
Appreciate
Enjoyed
it.
it.
All right, we can get started. Our last but not least, smart high efficiency wind turbine for highways. We look forward to seeing your presentation. The floor is yours.
All right, thank you, Dr. Jinwoo Lee. So hello and welcome to the final presentation of Track 4 for the ECS Virtual Showcase 2020. This is the Smart High Efficiency Wind Turbine for Highways with accompanying algae filter. This project was put on by 6 team members from the Mechanical Engineering Department, including Fawaz Al-Shamari, Abdul Rahman Al-Daihani, Faisal Al-Humayed, Nicholas Sawani, Sarah Al-Muhalej, and Faramars Ramizani. Next slide, please. All right, so our goal in this project was to create a clean system to generate electricity using a vertical axis wind turbine along highways and to provide clean air by means of an algae biofuel filter. In this project, we achieved this effect by harnessing wind energy from passing vehicles using a vertical axis wind turbine. And then this vertical axis wind turbine is used to power an algae bioreactor, which removes carbon dioxide from the air, turns it into algae biomass, which can then be used as a fuel. So you'll be hearing about that during this project's presentation. So a little background information to begin. In the past, windmills were used to grind grain and to pump water. I'm sure we've all heard of that. However, what you may not be aware of is that wind turbines got their start in the 1970s, especially in Europe. Wind power energy has widely increased around the world since then because of the rising prices of gas and because of the increasing interest in renewable energy after the 1970s. As you can see, over the last couple decades, it has exponentially increased so that to the point where today, it is very likely that there are over 450 gigawatts of wind energy currently being used at this moment. So wind energy is a very powerful source for current energy needs. As you can see, one of the pressing concerns for our area in regards to the air is how polluted it is. So here's a graph of the Southern California region indicating the number of trucks per day which travel along Southern California freeways. As you can see along the 710 freeway and the 60 freeway, there are over 20,000 trucks per day. Along Cal State Fullerton on a typical day, we can expect as many as 10,000 trucks to pass. As you can imagine, this causes a lot of air pollution. This makes it very harmful to live next to highways. And this air pollution contributes to some 4.2 million deaths every year due to air pollution. So, put it all together and we're coming up with a solution. here we go. There are two basic solutions provided by algae bioreactor systems. The open system, just an open tank of water with algae growing inside, and the closed system, where the algae is pumped through tubes. These are both currently on the industry right now, being produced, being worked on as a clean energy solution, which is also very capable of removing a great deal of carbon dioxide from the air. So here we go. I'll tell you a little bit about these two options. Our system, as you'll find out later in this presentation, is a combination of both. Kind of a fusion of the two, but we'll give you a kind of basic understanding here. So an open system is the natural method to culture algae, much like the ocean. Sunny areas are preferred by the algae because they need, light for photosynthesis. Considering their low maintenance and construction costs, they are a very good option. Closed systems, however, such as the photobioreactor, are much more popular in industry right now. They provide a controlled environment to culture algae, and it can be manipulated, this environment, to accommodate a variety of species, which may not be, entirely native to the area in which the bioreactor is being implemented. Every parameter, including carbon dioxide level, water supply, temperature, and nutrients in the water, this can all be controlled within a closed system. So I'll pass the mic on to our next presenter.
Yes, as Nicholas explained about the project, so the objective and goal of this project is to use a highway as a source of the energy, the wind energy. And so we're going to transfer the wind energy to the electricity, and also we're going to use it to capture the CO2 and also change the algae to the biofuel. So for these goals and objectives, so we come up with a design. So go to the next slide, please. So due to the limitation of the time, so we just come up with a very basic design in this presentation. We're not going to get detailed because we don't have a time to explain everything. But so as you can see in this basic assembly, so we come up with a design. So we're going to install the U-shaped PVC, U-channel PVC on top of the jersey barriers in the middle of the highway. So we're going to flue the algae with the water, so in through of this U-channel. So, and also we're going to install the turbine, the wind turbine on top of the U-channel. So wherever we need actually to install the turbine, so we come up with a cap. So we have a cover, so it's going to be the metal cover. We're going to mount it on the top of the U-shaped channel. So, and also the U-shape is going to mount it to the barrier as well. So we're going to actually install this one in the middle of the highway. And so by passing the car, so we're producing the electricity. Also, we're going to flue the water and algae into the channel. So we have a pump. If you go to the next slide, please. So in the middle of in the bottom of the channel, so we do have a pump. So we're going to use the same energy as the wind energy to make a power to running the pump as well. So we're going to flue the algae with the water into the channel. So basically it's a combination of the closed and open system both together, as you can see here. So, and we're going to analyze the highway every 20 miles, 10 miles, or 15 miles. It depends on the highway. We're going to collect algae after a few days, and we're going to transfer it to biofuel after that. So here is the design, and so this is a prototype which we make it. But as I said, due to the limitation of the time, so we're not going to get to the detail of the connection, installation, and the analysis, and yeah, so those actually is going to be in the full presentation PowerPoint.
Okay, for our project activity, the team has performed some of project activities such 3D printing to use it further for the project, some of the project parts. Also, we needed to study a lot about the algae culture. So what we were focusing on the last few weeks was focusing on making experiments to study about the which kind of algae gonna use, and the lifespan of the algae, and how much it's gonna produce of CO2 and capture CO2. So our plan for the experiment in campus, it was the following. We had one water like glass capacity, 1 liter of glass capacity, and the setup as instructed in our like researches that we have done, 20 milli of water for the amount of 500 milli of algae, and we have measuring ruler and carbon dioxide detector, and for sure we needed sunlight. So the procedure was to add 25 milli of water into the jar that we have, and 500 milli of algae was added to the mixture to measure the carbon dioxide detector used in the measure carbon dioxide concentration. At the beginning of the experiment, in day 1 and day 2, the mixture was annegated and placed in open air, and the color of the mixture was monitored for the 3 days. The result and outcomes, the summary of them for the best 3 kinds that we have done experiment on. The first type was Athrospira. The readings that we have in our detector, it was part per million, 26 part per million in first day. On the second day when we checked on it, it was 9 part per million. And day 3 was 0. So the reduction from day 1 to day 2 was 65.5%. The third day was 100, and the second type, it was the chlorofluorgus. The readings was 22 parts per million, and the second day was 0, and the third day was the same. The reduction was 100, which is the kind that we chose to use, also based on researches, but we want to just double check how effective, because the researches that we were focusing on, it wasn't meant for using as a filter. And the third type, it was the preformant. It was 26 parts per million. Second day 11, and third day was 0. So the reduction in first to second day was 57.7. So developers, practical design to use in highway, easy to maintain, better than existing solutions such like having trees on highway, which is gonna be hard to maintain, and it can be dangerous in case like of accidents. The turbine can generate enough electricity to be used in many applications. In our case, we're gonna use it for the fan, for the filter, and we also can use it in many applications in the future if we can reach like a lot of generating electricity from passing cars. Dissemination, our team have attended Southern California conference for undergraduate student, and we have gained a lot of ideas. That was last fall, and we have changed our design with the advice that we have got from audience. Thanks for listening, and if you have any questions.
Thank you for a great presentation. Again, if you have any questions, please send them to me directly through the group chat. So the question from the audience, can you tell us more about the algae biofuel?
Oh, yes, thank you. I can handle this question. So algae biofuel is a very up and coming thing on the market. So you may have seen videos or on YouTube, advertisements, or even on television. You may have seen advertisements about companies, even oil companies that are getting into algae biofuel. So it's a very hot commodity on the market right now. It's already been implemented at some large public locations like Heathrow Airport, where sunlight is being utilized to grow algae biofuel. So it's like it's a lot like ethanol. This is like another solution to oil issues and such. So it's like ethanol. Yeah.
What are some challenges of using algae as biofuel?
like the most hard challenges that we had to spend a lot of time doing researches based based on like the knowledge we just have, which is minimal comparing to choosing what type and to figuring what is the maximum and why we're gonna use it as a solution.
Yeah, it's a lot of things are still being researched. We contribute a little bit of research ourselves. There's many types of algae out there in the world, millions probably. So choosing the best kind and the best process for developing a fuel from them is still an area of ongoing research. So what we've provided here is one possible solution and one possible means of implementing this kind of thing widely in our locale.
Thank you so much for that answer. Well, those are all the questions that we had. Thank you again for sharing a great presentation. And that also concludes our virtual ECS showcase, track number 4. Thank you everyone for participating.
Thank you, Dr. Lee.
I really enjoyed seeing everyone's presentation and all the hard work and effort that went into it. So great job and congratulations to many of you who will be graduating this semester. And best of luck